Okay, here we're finding the area of a sector of a circle. And we have a circle, and the sector here is this part right here. It's this piece of a pie. And we are looking at the central angle as being theta, and theta is in radians. Even though a lot of people like to use degrees, for most formulas we present, they're using radians. And here you have R. So the area is A equals 1/2 R squared theta. Now, we could derive the formula by using the fact that the area of the circle, or actually the disk, but anyway, the area of the full circle would be pi r squared, and we can look at it through that. But then how did we get that formula for the area of a circle? Well, you're going to have to use some sort of calculus. We feel so familiar because we learned that, already in an algebra class maybe, or even earlier. So, but in fact, it was derived using some sort of techniques that are like calculus. You can do an explanation where you can say, well, here's the area of the sector, and you could look at the area of a circle. And you could look at this as related to theta, which is, the angle measurement. So this is the angles and the angle of the sector. And then you could look at 2 pi, which is the angle of the circle. So, the proportions should be the same. If you look at the area of the sector to the theta, it should equal the area of the circle to 2 pi. And so therefore, if I multiply this, I should have area of the sector is equal to area of a circle divided by 2 pi times theta. But we have a formula for the area of a circle, that's pi r squared. And then we cancel out and get the what we thought we would have. So that's a way you can explain that. And so, for example, we can find the area of the sector of a circle with radius r equals 3 inches and theta equals pi over 6 radians. And almost always we don't write the word radians. So therefore the solution is that we use the formula. I would say most people don't remember this formula, but we use this in Calc 2 when we find areas. We do more things with trigonometry and circles. Okay, 1/2 pi r squared, which is 3 squared, and then times pi over 6. So, okay, why did I put the pi there? Sorry, I started daydreaming here. So area is 1/2 r squared theta. Sorry, I didn't write down the right formula. So area is 1/2 r squared theta, and so I just plug everything in there. So this is going to give 1/2 times 9 times pi over 6, and then there's a little bit of figuring things out, but this makes 9/12, which reduces to 3/4 pi, and that'll be units squared. So I guess I better put that in there. Inches squared, square inches. So what is this all about? This video is giving this formula. And really just actually, yeah, giving the formula and defining what a sector is of a circle. As far as using the formula, that is, that's sort of elementary, like pre-algebra stuff. You put in the value of r and theta. But here's the formula, and a sector is that like piece of the pie. So it's what's the area of that pie that you're eating on Thanksgiving. This was an attempt to explain this, given the fact I know the area of a circle. The area of a sector to the angle measurement is equal to the area of the circle to 2 pi, because there's 2 pi radians in a circle. And then if you cross multiply, it simplifies to area is 1/2 r squared theta.